Alrighty, good afternoon, everybody. And today we should really talk about lecture number 8, which will be covered in your written test number 2 next Monday and Tuesday. And as usual, let's make some brief announcement. I do have 2 Google Doc questions as far as I could see before the session. And of course, if you got any other questions, feel free to ask or interrupt. We can definitely do that. Quick announcement. And your lecture week number 9, even though it's not really covered by your written test number 2, but it's definitely important for your learning and for your exam. I will release that either later tonight or very early in the morning tomorrow. Okay, just stay tuned. Okay, I know you do have to prioritize about which one to study. I would say maybe study just a bit about week number 9. Don't really wait until the midterm or the written test is over and then you will catch up. That might be too late. Just study a bit. Even 10 or 15 minutes per day will be okay. You definitely want to catch up with the new stuff, right? Because remember, the exam eventually is going to be cumulative. It's going to cover everything. So you definitely want to plan ahead. And for your week number 9 lecture, we're going to talk about tree traversals, which will be a very interesting topic. That one definitely will train you to really think recursively. You can look forward to it. And also, we're going to talk about another specialized kind of tree. You can think about in week number 8, we talk about general tree being a nonlinear data structure. And we talk about binary tree being a special kind of a general tree. And that's why we can derive so many interesting mathematical properties from the binary tree. And for week number 9, we're going to talk about another special kind of tree called binary search tree, BST. That one there also got very interesting property we have to learn about, and then we'll see some implementation as well. And yeah, and I think at least for week number 9 and week number 10, we'll still talk about trees in general. And then for week number 11 and 12, we'll see what we should go. Maybe we should really do more recursion. Maybe we should talk about also. I still haven't talked about hash map. Graph data structure is not really required for this course because in EECS2011, the design analysis of algorithm course, your instructor will talk about graph extensively. So that's why we don't normally have to cover too much about the graph data structure. We'll see how the time goes. I definitely want to make sure you understand everything about trees and also everything we covered so far well. I think that's more important when you graduate from this course. And for your assignment number 2, just don't forget it's been released for, I think, just more over a week already. And don't forget the deadline is next Tuesday, I believe. I can check the PDF for the instruction. Please make sure you submit before the deadline. If you got any trouble finishing off the task, or if you really get stuck in one of the tasks, feel free to reach out to me. Email, appointments, or maybe office hour. I'll be more than happy to go over whatever solution you may have that you get stuck. And about your written test number 2 as well, right? Just don't forget, the guide has been released. You should really check it for the opening time and closing time for the test. It will be very important for you to obey that. Do you guys have any questions in general about the course before I talk about the technical stuff? Anyone? Okay, good. Yeah, it's okay. Yeah, I mean, thank you telling me no. Yeah. Okay, see from Jared. Is the written test 2 the same difficulty as 1? I can tell you that naturally, written test 2 would be more challenging than test 1 because we actually cover more the more advanced stuff. For example, we talk about doubly linked list as opposed to singly linked list. And also we talk about dynamic arrays, we talk about circular array, and we talk about tree. You can see those topics naturally will be more challenging than what we spoke about in the written test 1. So I would say, I'm well aware of that you guys only got 30 minutes for the test. So I think you might find that the question itself might be a little bit more challenging than before. But I think you still, I'll make sure you got enough time to think about. Of course, you cannot be unbounded amount of time. You have to make sure you're reasonably familiar and also understanding about the material. That's what I would say. All right. Any other questions? All right. So assuming that everybody's comfortable with the course so far, let's now talk about Google Doc question. I got 2, which I just checked before the session. All right, the first one here is more related to Java implementation about generics, which is good. I'm glad somebody actually asked this question on the Google Doc. I mentioned that very implicitly in the lecture, but I think this might be a good time to clarify that, because I'm pretty sure you run into such compilation issue or runtime issue, especially for the class cast exception. Whenever you want to create an array where the element type is actually generic, you have to be careful. It turns out the workaround solution is not that beautiful. It's quite ugly, I would say. But that's the way it is in Java, right? Unless you program in another OOP language, otherwise, I would say we have to deal with it. We have to live with it. Right? Let me try to summarize what you have to do whenever you try to create a generic array. And of course, you don't really have to, at least for your written test number 2, you don't need to memorize the syntax because it's open book. You can definitely make the syntax handy in case you have to check. Okay. Let's take a look. The question is, when exactly do we use? And for those of you who already went over the lecture on week number 8, you would have seen something like this: array.new instance over here, this.get class, and maximum number children. And by the way, you don't need this for assignment number 2, because remember, for assignment number 2, you are not allowed to actually use arrays. So this is not relevant to your assignment number 2. I'm just talking about Java in general, which we spoke about in the lecture. Okay. So when should we use this syntax over here as opposed to just use a new objects array and then cast that to the corresponding type? You have to know which one to when to use this one here and when to use this one here, right? The distinction is not really too bad. Let me show to you. So far, there are 2 occasions where we talk about this kind of syntax of initializing a generic array. 2 occasions. The first time we spoke about it was when we talk about the queue or the stack ADT. Right? So both are the same. So let me just choose one of them. Let's say when we try to implement this class over here, array queue, which implements the queue interface, remember? And we declare, just notice that this is a generic type, generic parameter E over here. And then we are declaring the data array, which is an array of E. And this will be very important to notice right away, right? Over here, you can see here the element type. Elements in array, each one of them have the type E. Right? That's quite obvious, but it's actually important for you to make the judgment. In this case, if you actually want to initialize an array for data, right, what you gotta do is you have to say new and then objects and then whatever capacity it is, and then cast it to the E over here. If the element type for the array is only about the generic element E without any further classes wrapping around it, in that case, you can definitely use this syntax over here without any class cast exception. However, if the element type for the array goes beyond just E, which we'll see one example in a moment, in that case, you have to use another workaround without this. Okay, let's talk about that example, which is what we spoke about in week number 8. Okay, remember we talked about a tree node class over here. And remember we got the attribute children storing the list of child nodes for the internal nodes, and every element in the array has the type not just E. E is wrapped around within another generic class called tree nodes. So this will add the extra complexity so that you cannot really use this kind of syntax anymore. Okay, let me make it more precise. So if you look at this part over here, this suggests the type of every element in the array. Right? Let me write it down over here. So for this one here, each element in the array has the type tree nodes of E rather than just E. Tree nodes of E. Right? It's really important for you to really compare and contrast these two. In one case, the element type is only just E. That's the simple case. In the other case, the element type is not just E, but E is wrapped around with another generic class. So that will be complicated enough so that you cannot really do what we did before. So let me show you what would be wrong to do, which I also mentioned in the lecture. Let me write it down over here. And let's say over here, if you actually say this dot children is assigned to, if you're trying to follow this kind of syntax over here, let's say you say, I want to cast that into tree node of E, and then it's an array, right? This part is really the same, just about the casting part is really the same between the two versions. But if you only do the object array, like in this case, let me finish that and then I'll tell you what might be wrong. And the object over here, and then you put some number over here, right? If you do this, it's going to give you a class cast exception. At the moment, it simply wouldn't work in Java. Okay, I really have no idea why it wouldn't work. I think it might be subject to some internal implementation for the Java language, so which is beyond our control. So in this case, you're gonna get class cast exception. Which you guys learn about in 2030, about what a class cast exception is. Okay, so don't do this. If you actually got the element type of the array, there's something beyond just generic class. So what should you do? What you should do instead is to do this. You're going to call some helper method from the array class over here. So you're going to say array, and apparently the new instance method is static. So that's why you can simply use the method without creating an instance of the array as a context object, right? That's something we know about the static method. You say array, the new instance over here, and here there are two things you want to supply. This part over here is about the size of the array. That one's straightforward. So this part over here is about the length of the array. This part over here is a little bit trickier. Actually, let me ask you guys this. Do you guys remember when you saw this in 2030? You guys remember? In what occasion did you see the use of get class? Okay, anybody answer? You guys learned about this syntax over here actually for 2030. But do you remember which context? Anyone? This might appear actually in the assessment. From N, very good. Equals method, exactly, right? Very good. So the get class basically is going to figure out the dynamic type information for some objects. All right, very good. So the get class over here is really to retrieve the information of the dynamic type of this. What's really this? This, because now we are in the context of the tree node. So this is actually going to return to you the dynamic type this. And that one there is going to return the information back to the array.new instance. So think about what's really happening over here. In some ways, it's kind of similar. What we're doing is we are trying to create a new array of certain size. And dynamically, every element there in the array should be of this particular type. And the type is based on this get class over here, which is tree node. That's going to be ensured when we try to cast the whole thing into an array of tree node, we wouldn't run into any class cast exception. Right? That's a workaround. And that's something I think at this point, since you already finished 2030, so it's not really too bad for you to kind of understand how this workaround works. Any question about the clarification I'm trying to make over here? Anyone? For the first example, green box, good. Can we just say data is assigned to, nope, you cannot. Maybe there's something I try in the, I don't quite remember if I mentioned that in the lecture, no? From Asado. If you try, for example, you say data is, I can give you some, well, of course, if you only say E array, this one simply wouldn't work because you don't have the new keyword. I think what you meant to say was data is assigned to new E, right? And then pass some value over here. To be honest with you, I totally agree with you. This should be the way to go for both cases. I definitely agree. However, it's not the case for Java. However, this one wouldn't work. If you try that in Eclipse, it simply wouldn't compile for some very peculiar reason that's to do with a Java compiler. But that's really, I would say that's maybe most ugly part about Java, I would say. but we just have to know how to work around it if we want to stick with the language. How will it know about how many bytes to reserve if you do that? Which one? Are you talking about this one over here or this one over here? In both cases, of course, it would know because for Masato, you're talking about this syntax over here, right? Yes, indeed. Maybe Masato really meant to put some numbers over here for sure. Every time you want to initialize the array, you have to pass some size over here. You should. So that's why even if you pass the size, even if you use a new keyword, it's still not actually going to compile. Right, guys? As I said, it's really some issue that's not really based on logic. I'm just trying to explain to you what will be the workaround. The workaround itself makes sense. But ideally, Java should really make this syntax work. I totally agree. Okay? But it's not the case, I'm afraid. Already, any questions to follow up? I think it's a very valuable implementation detail for you to know. I think it's definitely learn it if you guys are gonna stick with Java. Yeah, so parts about the accessor method, yes, that'll be the next one. Yeah, don't worry, I'll get there. Yeah.
Hello, Professor.
Okay,
sorry.
any follow-up to this, guys? Anyone?
Hey, Professor, sorry for interrupting. I was saying that I posted the ancestors method by mistake. I wanted to look at the solution for the descendants.
Descendants. Okay, that's fine. I didn't know that was a mistake. But I already prepared the full solution for the ancestor. I'm gonna go over the solution with you. So why don't we do that together anyway? However, I think the way you calculate the descendants will be very similar to how you calculate the ancestor. It will definitely give you enough inspiration. How about we do that?
Because I got the ancestors, but like I was trying to implement the descendants in like a similar kind of way.
Yeah.
But
I think for the way maybe let me show you my pattern of solution first. The way it works, it will be just with a few more extension to my solution to really get the descendants work. Maybe because your solution might be too specific to calculate the ancestor test. That's why it cannot be adapted for calculating descendants. Let's go over my solution first. You can take a look. If you still have no clue, you can still come to me. We can talk about it still to follow up. How about that?
Okay.
Okay. No, that's okay. Yeah. I'll get to your question. No problem. It's definitely on my next page. I didn't forget about it. Okay.
Yeah, thank
you. Okay. All right, guys. Just I want to make sure you're comfortable. So are we okay with this part over here? Everybody's okay? Okay. Well, if you want to program in Java, most likely you have a program in generics. If you do that, you definitely have to know the trick. Okay. Already hearing none, seeing none. Let's now move on to the next one. That'll be the second question I saw in the Google Doc. Okay. So it's actually okay. Now I know it's posted by Parth. Okay. But even though it's by mistake, Parth really meant to ask about how to calculate the descendants. But I would say the way you calculate descendants would be very similar to how you calculate ancestor. Think about it in this way. Let's say for Elsa, right? How do I recursively calculate the ancestor? I just have to somehow go with the getParents accessor method recursively until I reach the root where the getParents is simply null. So in the case of the getDescendants will be symmetric. What I gotta do is, let's say I still start from Elsa. I have to somehow maybe use a for loop or while loop to really go over every child nodes I might have, which can be arbitrary number because it's a general tree. In that case, for every child node I'm seeing, I need to somehow maybe add them into the array or to the array list, depending on what return type it is. And then you got to do this recursively until you reach the base case, which might be some external nodes, in which case they don't have any child nodes. It might just be null. So that's kind of the idea. And of course, this will be quite relevant to your assignment number 2. Maybe that's why you were kind of asking me. That's okay. I think that's might be good help to your assignment number 2. Of course, the difference is in assignment number 2, as Jared pointed out, you are not allowed to use array. So, but I would say the logic we are talking about over here can definitely be somehow applied to the case for assignment number 2. In which case, you're going to use some maybe the syncly linked node, which you learned about earlier. But you cannot use array for assignments, and you cannot use array either in the programming test. We really want you to get used to as much as possible in this course using linked structure, not array. our main learning outcome is not the array in this course. That was the previous course, maybe in 1022 or 1021. Okay, so let's now talk about this ancestor calculation. I don't think I need to really do this together with you in Eclipse. The method itself is rather straightforward. I'll go over with you line by line just to let you know how it works. And then you can program that into Eclipse yourself, and then that will definitely help. Okay, why don't we do that? This will be some test cases over here just to show you. Let's say before the test case, we already set up this particular tree. You can find those lines of code to set up this tree in your example code for lecture week 8. Okay, and then let's say this. Let's say we want to calculate the ancestor for David. David is actually the root of the tree. In that case, what about the ancestor? It should be only David himself and nobody else, because David, the get parent, is going to be null. So that's why the return value from David, getting the ancestor for David, should be some array, right? You can see the return type is actually an array. So ancestor that length will be just 1. And the array at index 0 should be just David. Just one example. What about the ancestor for Ernesto, right? Ernesto is actually over here. So the ancestor should be starting from himself and then his parents, which would be David. So the ancestor should be 2. So the order will be starting from the node and go all the way to the root, the ancestor path that we spoke about in the lecture. So that's why you'll be Ernesto and followed by David. And let's do another one. What about Vanessa? Vanessa will be basically Vanessa herself, and then to Elsa, and then to Chris, and then to David over here. I would say the trickiest bit for this implementation over here would be, since we are using a primitive array as the return type, you have to make sure the length of the array corresponds to the number of ancestors you have for the node. For example, if I ask you about the ancestor for David, the size of the return array should be 1. If I ask you about the ancestor for Ernesto, the length of the return array should be 2. And again, if for Vanessa, the ancestor should be 1, 2, 3, 4, length 4 for the return array. Right, so far clear about what the problem is about ancestor? Yes, ancestor. And of course, you're supposed to really understand about all the terminologies that we spoke about general tree and also binary tree. That's really the base, the main learning outcomes for lecture week 8. Any clarification needed about what we're going to program for this? And then I'll show you the solution. I'll go over that with you as well. Everybody's okay? Alrighty, let's now go over the solution, okay? So the solution is actually over here. Okay, let's go over line by line quickly. And this, we actually got the method that we are supposed to program. You can see that's the, let me try to highlight it. We got ancestor, right? And the input is some tree nodes, which might be the root of some subtree, right? So n over here can be David, n over here can be Elsa, n over here can be Shirley, can be any of the nodes in the tree. Okay. What about the output? The output is an array of tree node. This is why it will be. This is why the workaround syntax that we just spoke about, we will need it. I'll talk about it in just a moment. Okay. First of all, just understand about the return type and also the input parameter type for this method over here. Okay. The way I'm going to do it is I'm going to first of all calculate the size of how many descendants we have for this particular node. In that case, we can say we just define some recursive helper method, number of ancestor, and then some node, the same node. Okay, so this is going to be computed by using this helper method over here, right? Let's take a look at this. This one is rather easy. Calculating the number of ancestor is pretty much like calculating the depth of the node, similar. Okay, so the base case would be if the node's parents would just be null. For example, in this case, David. David has no parents. In that case, itself will just be considered as 1 because a node is its own ancestor. And otherwise, we're gonna say 1 to count the node itself, and then plus recursively calculate the ancestor for the parents of that particular node. What do I mean? Let's take a look. Let's say if I want to calculate the number of ancestors for Elsa, right? The way we do it is by calculating in the following way. So Elsa herself is going to be considered as 1. And then we're going to recursively calculate the number of ancestors for Elsa's parents. In this case, it will be starting from quiz, right? And this one over here will be the number of ancestor of Elsa dot get parents, right? So that's kind of how the recursive method will work, right? That's exactly what we just wrote over here, right? So this one here is rather similar to what we did for the depth, and also yeah, it's more similar to the depth method that we did in the lecture. All right, so this one should be good. So once we calculate how many ancestors there are, we're going to initialize an array of that particular size, right? You can see over here, the size is going to be calculated over here and used over here. And in this case, you can see the element type for the array is not just a single E, right? As I said before, in that case, you will have to actually use this workaround syntax over here using array.newInstance, right? But what I want to speak about is this particular part over here. Rather than this.getClass, we cannot use this.getClass because if you say this.getClass, in this case, which class is it really referring to? Is it really referring to the tree nodes? It will only refer to the tree node class if the method is actually resides in the tree node class, but it's not the case. This method will be put under the tree utilities class. Right, similar to the depth and also height methods in week number 8. So if you put this method over here in the tree utilities class, in that case, you cannot say this.getClass. That's not the way to go, right? What we gotta do instead, because the root over here n has exactly the dynamic type that we need, because every element in the array will need this class as the element type. So that's why I say n.getElements. So notice the use of the get class. I think I tried to study this very carefully and compare that with what we did earlier about the tree node example. The class where we put the method is different. In this case, it's the tree node class. That's why we can say this.getClass. On the other hand, in this case, this method over here is going to be put under the tree utilities class. So that's why we cannot say this.getClass. We have to say n.getClass over here. All right. Finally, once we initialize the array, we just call it list appropriately to the right size. We're going to call our recursive helper method to fill in the array. So we're going to pass the root, we're going to pass the array, call by value, and also 0 over here will be the starting index. The start index to store ancestor. And we're going to increment the value for this index over here every time we make a recursive call. Let's see. Okay, so you're going to see that this is the recursive helper method that we're calling. So this is ancestors helper over here, right? We got a tree node, and also we got the array, and we got a current index I. I'm going to say that if the node that we are talking about is not really equal to null, because you can think about there will be one call where we say that the David.getParents. In that case, getParent is actually going to give you null. The null over here passed into an ancestor helper should really do nothing because we cannot do anything with a null node for the parents. Okay, so that's why we got this edge condition over here, and then we'll say list. Think about what's happening over here. If this is the list array, and of course, it's going to be filled in from left to right. And if the current index is actually I is actually going to store whatever node that we are talking about, right? It's going to store to wherever node is actually pointing to. So this will be some tree node somewhere in the tree. That's basically what we're doing. And then want to make sure that we say I+1 for the next recursive call. All right? Right, so that's about how the method should work, right? I would encourage you to really understand the fragment over here, and then I'm going to make the notes available to you, and then enter this into Eclipse, and then make sure it works. Parth, are you following about the ancestors method?
Yes, Professor. I'm clear.
It's kind of similar to. I wonder, is it similar to how you did it, or it's kind of different?
I just did it using a loop, so just a while loop while.
I see.
Yeah.
I think I can tell you the main points about assigning those exercises to you is to really do recursively. So now that you know about how to do ancestor, descendants should be very similar. I'll leave that to you. Okay.
Yeah.
Okay. Awesome. No problem. Okay. Guys, any follow up to this question over here? Right? Anyone? Yeah. Let me highlight again. The reason that we have to use the array.new instance over here is because the individual array element type is beyond just a single E. So that's why we have to use this workaround. Ugly, but we got to live with it. All right. That's about everything I saw in the Google Doc. Right? I don't see anything else. Do you guys have any questions for me? You can open the floor, and you can even ask me something that might that's actually happened maybe earlier in the lecture. That's okay. Right? Any questions? Yeah, going forward for the course, I think we still got to cover binary search tree, which I will talk about in week number 9. And in week number 10, most likely I'll talk about the so-called balanced binary search tree. We're going to talk about how we can do some interesting rotation for the tree. That's kind of the most exciting part for the tree. It's really amazing, like how you can really try to do the visualization about how you can rotate a tree. We'll talk about it in week number 10. And then hopefully I can finish that. And I will also need to revisit back to the recursion lecture. So far, we only did binary search and also deriving the running time for the binary search. I definitely still want to cover merge sort and also quick sort. I really also want to cover the Tower of Hanoi, which is a very interesting recursive problem to solve in Java. I'll see what I can do. And then we still got 2 more lecture, 11 and 12. In that case, I'll definitely need to cover hash table and also the map ADT. I think that's something you need to know before you move on to maybe the 3rd year. In terms of the graph ADT, I may not be able to cover as much as I would really like to. What I can do instead, maybe for your learning, I can maybe just cover some very basic about the graph. And that will be about what I need to cover in the exam. But for those of you who might be interested in doing some self-study, I can also include some other additional slides for your self-study. You can look at that maybe during the summer if you want to, before you take 3101. But as I said, usually your professor in 3101, they will actually cover the graph from scratch anyway. So there may not be any point to overlap with them. Okay, I'll reach out to you about the arrangement later. Okay. We are not going to be expected to implement quicksort during the test, not quicksort specifically. However, remember the background study on the recursion I recommended. So you may be asked to really implement some recursion to that level of difficulty. You might be, maybe not quicksort specifically, because I literally want to cover quicksort in later. So I wouldn't ask you before I cover that. But for the recursion coverage, you definitely should know how to implement recursion for sure. And what should be the level of difficulty? You should really study all the background easy problems, and also to study the extra challenging problems which we went over in the earlier Q&A, right? So you should really know all of them. For the opposite case for descendants, okay, we talk about calculating descendants. If you want to do it to do this recursively, would it be correct in saying that you need a loop? Yes, indeed. Plus recursion. Yes, I think so. So let me just clarify that just from Ali over here. When we try to recalculate calculate the ancestor recursively, in some ways much easier. Well, I shouldn't say much. It's in some ways simpler because every time you simply just go for one link, unique path to your parents, right? And in the case of getting descendants, for example, for David, in that case, you will have to somehow to say, I want to go over my child nodes one by one. Of course, it's a general tree. So the number of child nodes, it can be arbitrary. It can be 5, can be 2, can be 1, can be 0. Gotta go over each one of them, and every time you see a child node, you have to recursively calculate their descendants. So you definitely need a loop, and you definitely need to call make a recursive call on every child node. Yeah, for sure. Can we have a recursion branch for each child node in parallel? I presume you really meant you want to compute the recursion all at the same time, right? I think that one may not be up to our choice. I think it's kind of up to how the programming language is going to be executed at a runtime. For example, let's say this: if your computer is single core, well, it may not be so common these days, but let's say if somehow your computer is single core, in that case, it doesn't matter if you actually got multi-threads for your program; it will still be executed sequentially. So I would say how exactly the computing is going to be done at the runtime, either sequentially or maybe distributed to multi cores, is really up to the scheduling at the runtime, but we cannot really control that. But of course, you might be able to, I'm guessing, you might be able to maybe use the threading mechanism in Java to say, I want to maybe do this recursion on this child node in one thread. I want to do every child recursion on a different thread. In that case, it might be able to do some parallel computation. It might be. But using threads will be beyond the scope for this course. For those of you who might be taking 2031, the C course, what you can do is you can try maybe for your own personal interest. I'm pretty sure you guys cover about how to do threading using the threading library in the C system library. I guess I did it when I was a student at York. It is a long time ago, but I'm pretty sure the library still exists. You can somehow do the similar kind of computation for the descendants, but you can somehow say every time I will try to make a recursive call on a child, I can assign a particular thread to it. In that case, it might just be able to do parallel computing. Okay, that might be the way to experiment. Right. Good. Awesome. All right, guys. Any more questions? And by the way, what I just mentioned about parallel computing or concurrency, you may have heard about this this term before. We don't really cover any a concurrent algorithm in 2011. It might be a little bit too advanced. I don't think typically in 3101 they will also cover any computing like a concurrent algorithm. But I think it might be something, if you're interested, that may be something you can do in your own time for your own interest. It's challenging, but it's something I think a CS or software engineering graduate should know. But again, beyond the scope for this course. Alrighty, guys. Any more questions? Any more? Oh, just for you guys to know, I'm going to make an announcement a little bit later tonight. For tomorrow morning, unfortunately, I cannot really make it to the 8:30 Q&A section. So I will need to cancel that. I'll try to make up the hours for you guys, maybe for later. But if you still got any question that you really plan to ask me tomorrow at 8:30, so please, you can drop me an email. That's okay. Or if you want to drop by my office hour tomorrow at 2 p.m., you can also do that. But I'm just saying I cannot make it to the 8:30 session tomorrow. I will resume the session maybe next week. All right. Yeah, about an example question for test 2. It's still on my to-do list. I'll try to get to it either today or maybe later tomorrow. I'll definitely make up some question for you guys. I think that will help. In the very worst case, if I really cannot, I'll give you guys maybe some example question. I'll give you some tips about which area you should really focus more on studying. But I think the format for the question is going to be identical to what you experience in written test number 1. But anyway, I'll try. Either tomorrow, later tomorrow or Friday morning, the latest. I'll try to give you guys some example. There are going to be programming test 1 solution. Yes and no. Yes, in the sense that if you look at the Q&A from March 2nd, we spoke about how to implement the shifted to the left. I forgot either shifted to the left method. That one is actually done by people who took the test on Monday. So that one there, you can look it up, and then that's a solution. For the other one, which is about removing all the instances, all the occurrences of a particular value in the list, that one you can maybe try to do complete it on your own. And if you want to go over your solution with me, you're more than welcome to. But we already went over one of them. Okay. Will the test be weighted more towards trees or stacks and queues? I would say you can think about the number of lectures we have covered, right? I think you definitely can cover anything that's actually in the lecture materials. I would say for the trees, it might be more to the very basic level for the trees, because we haven't covered a lot about how to program recursively on the tree. But I think you can definitely expect some questions about mathematical properties for the binary tree. And also, I might just give you some simple, let's say, like a simple methods to really implement on a general tree. For example, I might just give you depth to implement or something along the line. And you definitely should also review dynamic arrays, amortized analysis, and also circular array, right? I think every subject we cover in the lecture material, they're crucial, right? And think about what you're doing now. Yeah, no problem. Think about what you're doing now for the study is really will do you good, towards the final exam, right? I think it's actually kind of nice, to have some late turn test towards the end of the semester. Okay. All right, guys. Any more questions before I might let you go earlier? Already seeing none, hearing none from the chat. Okay. Guys, you're welcome, and then have a good night, and then any questions, any concern, reach out to me, and then I'll see you later. You guys take care, all right? Bye-bye.